Hello everyone, today I'm going to tell you a brand new material. It's called graphene. In fact, this week is Graphene Week. Scientists hold a conference to discuss this special material in Poland. Now you must ask, what is graphene? What makes graphene so important? So, actually, graphene is a thin layer of pure carbon. First, we can start with the history of graphene. It's the first material that is two-dimensional. This gives it some unique property we will talk about it later. Since 1859, many scientists tried to make graphene by very complex experiments. However, they failed to make it until 2004. Now we have to think, how can we make an item that consists of a layer of carbon, just one layer of carbon? How? Does anyone know? Okay, eventually scientists have found a very simple way to make graphene. It's by Scotch tape. During an experiment, when scientists used a tape to clean the graphite stone, they noticed that there are some small parts of graphene on the tape. And today, hundreds of laboratories around the world are dealing with the different aspects of graphene research. In simple terms, graphene is the thin layer of pure carbon. It's single tightly packed layer of carbon and are bonded together like a honeycomb. It is the thinnest compound and the lightest material we have known, and also it is the strongest material we have discovered. It is the best conductor of heat and electricity at room temperature. And also, graphene is the strongest material in the world, and it is harder than diamond and about 300 times stronger than steel. Graphene also conducts electricity much better than copper. Graphene is the transparent material which is bendable and can take any form you want. Now we have my member.
Okay, my name is Wei Junzhang, and now I will show you how to make a graphene. Just like slide, there are four main ways. The first simple, the most simple way to produce the graphene. Sorry, I have a little nervous. Okay, first, setting a graphite, graphite is on a bowl, and then stick it with scotch tape, and peel layers and layer until only single layer, and the product is pure and no chemical residue, but yield never enough for experiment or for lab for research. And the second way, reduce graphene oxide. We have known that graphite consists of layers, carbon groups, and there are van der Waals force between layer and layers. Scientists use powerful oxidant, let carbon and oxygen get together. Then oxygen functional groups with hydrophilic are stronger than van der Waals force. So we can get single layer or few layers graphene oxide. On the other words, imagine graphite is a brotherhood and oxidant is a hot girl. Okay, so someday when graphite and oxygen become a couple, they will leave the brotherhood. Yeah, and so we can get the graphene oxide, and we just need to kick oxygen out and get carbon. We can get the graphene. About epitaxial groups, I didn't find the detailed process, but substantially scientists use some method that silicon escape. So carbon will become single or few layers graphene, like that. And final way, chemical vapor deposition. It uses metal material as a vessel plane and flue gas including carbon elements such as CH4 methane in 1000 degrees Celsius, and graphene will appear on the metal vessel plane.
As we just mentioned, the history and the process of how to make graphene, then we will come to the topic, where can we use graphene? We all know that graphene is a one-layer material that is considered to be two dimensions. So let's see the picture. Do you know what is it? It's a medical sensor devices that it can count the hemoglobin, 红血球, hemoglobin levels in one person's body. And because it's applications of graphene, because graphene is just one layer materials, so it can be, on the other hand, it's really, really small. You think you can put in this kind of devices and it can count the hemoglobins to know how many it is, or even though it can be like applied on the sensor devices for cholesterol. And second is you can see it's the bone of our body, and because the graphene is really small, so it can apply on the tissue generations for the small part of our body. Like if you get harmed or injured in this a little part, then you can use graphene to rebuild your bone. And someone want to guess what it is? It's a kind of medicines, or even though it's a kind of treatment to cure cancer. So how it works? When graphene is, we all know that graphene is really, really small dimension materials. So graphene will combine with the medicines. And then the doctors will send this medicine into our body. And we all know that cancer is a kind of cell that it will grow really, really fast and internals. So when this kind of treatment sent into your body, then it will attach on the cells that it has been cancer, and then it will start the program self-death and let the cells go past that. So this part is the biological engineering that apply the graphene. And the other hand is the materials. That we all know that graphene is a one-layer atom thick. So we can imagine that it's really light. And also it's really strong as well. So it will apply on, like, everyone is similar to this. It's our cell phone. And it can be predict that the cell phone can be flexible in the future, because Graphene is strength and flexible. So when you apply on the touch screen of a cell phone, then someday maybe it can be imagined that we can have a flexible cell phone, like you can place your cell phone and put it in a pocket, then it will be really convenient. And another one is the aerospace, like the airplanes in the air, because we need a really light materials to make airplanes. So graphene is a really great choice for this. And also it's really steels. So when you apply on the airplanes, then it can be the alternative to like build a plane, like the cover of the planes, and it can be more light to fly on the air. And the last one is the ultrafiltrations. That means, do you see the layer of here? Here is the graphene layer, and because graphene is like only one layer of atoms, so the water can go through it. But the other things like sand or pollutions that can go through the graphene, so you can get your clean water after the water goes through it. And the last one is the engineer storage. We all know, everyone knows what it is. It's the photovoltaic cells that turn the lights into energies. And because graphene is more lower cost than the silicones, so it will replace the silicones to be the materials in this part. And another one is the battery. We all know that it will come to problems when you use your cell phone all day long. So you really want your cell phone to hold a lot of energies. However, if you want to hold a lot of energy in your cell phone, then it will take a long time to charge it. But if you charge it really faster, then maybe you have to manage, and you have to bury the inconvenience of run out of the energies. So when graphene is replaced in these batteries, it can be charged really faster, but also store a lot of energies. So this is in the graphene applications. In these three parts are also applied on the commercials currently. And it is really like an evolution in the materials industrial. So many companies have engaged in this part as well. Though it still has some problems need to come over, like how to make it more low price and low cost, and how to make it more efficiently. But we can predict that graphene will be a hot topic in a few decades. Thank you for listening.
Carbon into superconductors. Resistance is zero. Graphene is awesome stuff, and I know a lot of you out there think the same because we've actually received requests to do an update about graphene. Now this is a sheet of carbon atoms. It's just one atom thick. If you were to lay these one on top of the other, you would eventually have graphite, which is the stuff that's in your ordinary pencil. Or if you were to take a sheet of graphene and curl it so its edges met, you would make a carbon nanotube. One of the coolest things about graphene recently is that we figured out how to turn it into a superconductor. A conductor is able to conduct electricity, and some materials do it better than others. Copper cable's pretty good, for example. But a block of rubber isn't. It's an insulator. But even with good conductors, you still lose some electricity because of resistance. A material resists electricity flowing through it, and so some electricity is converted into heat. That means no matter how much electricity you pour into one end of a copper cable, you're never going to get the same amount out the other side. But superconductors are different. They have a zero loss carrying capability of electricity. As much as you put in, that's how much you're going to get out, and there's no resistance. Until recently, graphene was not one of these materials, but back in 2012, some scientists hypothesized that if you were to introduce lithium atoms at careful locations inside a sheet of graphene, you could turn it into a superconductor. And recently, scientists did just that. They were able to make a superconductive sheet of graphene. Now,
because the videos, after the video is another introduction, so we'll start in the video. And that's all. Thank you for your attention.
因为你们是材料系的。